Hello everyone, it is time for another Leet coding video. So we're still working on binary search. Let's get going. Alright, minimize myself here, and we're just going to do the next easy that we haven't done yet. This one is locked. Wah wah. Can't do that one. Okay, so first bad version. Okay, here we go. 278. First bad version. You are a product manager and currently leading a team to develop a new product. Cool, cool. Unfortunately, the latest version of your product fails. Darn. And fails the quality check. Oh, so I'm doing some bad quality stuff here. Since each version is developed based on the previous version, all versions after a bad version are also bad. Oh no, I done messed up this time. Alright, suppose you have inversions, 1, 2, 3, all the way to n, and you want to find out the first bad version, which causes all the following ones to be bad. Okay, so one of these versions is bad. I need to figure out which one it is. You are given an API, so bool is bad version. Okay, so I am able to call this API, so call this function, is bad version, and then pass in a parameter called version, and I'm guessing that this is just going to be an int, okay, which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of API calls. Okay, so this one right here is, I definitely see how this is part of that binary search kind of idea. So all we're going to try to do is essentially just do a binary search on this list right here. So we have the first element and we have the last element. Now we could just go, I'm going to check the first, I'm going to check the second, I'm going to check third, fourth, fifth, sixth, seventh, all the way up to the last element. Now that is linear because you have to check every single element in this entire list right here. Okay, but if we utilize the binary method, we're able to have logarithmic time because each time we're going to be cutting our data set in half and then saying like, okay, is this part of the bad version, yes or no? If it is part of the bad version, we know that all of the from the start to the end, no, not from the start to the end, sorry, from the start to the section that you just determined is bad, that somewhere in here the bad version is, and all of the other, like to the end, from where I'm looking to the end, all of that, yeah, all of that is going to be bad because the first bad version is not in there. So like, for example, we have a list here, right? So we're going to say like, well, actually good, 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 bad, here's the bad one, bad, 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 kind of like this. So we want to find the first bad element. Okay, so what are we going to do? We're going to look at the middle here and say, is it good or bad? And if this element right here is good, we know that all of the first elements, or the elements before it, are also good. Okay, so I say, all right, cool, that means somewhere in here is the first bad one. Okay, so then what I do is I only want to look in this section. Okay, so then I take the middle, which probably looks kind of like this one. Okay, so I take this one, say, is this good or bad? And you say bad. Okay, so now all of a sudden I know that all of these ones, because I'm looking here, I know all of these ones are also bad. So I'm going to say, okay, I'm going to look here, somewhere here. Okay, so now I'm only looking here. Then I say, I'm going to look at this one here and say, is this one good or bad? Okay, this one is good. So now I know all of these are good. I was looking at this one. All of these are good. And the bad is either, the first bad is like somewhere here, right? So then I can see that the bad is there. So again, with the binary searches, the problem that I always have is kind of, I can understand how I'm going from taking half and saying I'm throwing away part of it, I'm throwing away the other part, and I narrow something down, but I always get tripped up on the part where it's like, well, how do you actually, what is the ending condition, and how do you target on a specific element? So I guess I'm going to be looking, and it says here, like, I want to find the first bad one. Okay, so in this case, I don't want the first or the last good one. I want the first bad one. So that should influence me in what my stopping condition is, I think. So I guess I'm going to first start writing code and see how I might be able to do this. So left is equal to 0, right is equal to length, or is equal to n. Now n is the number of elements, right? So 0, this is 1 indexed, so I think we actually want n minus 1, because the last element is going to be equal to n, and this corresponds to the index n minus 1, right? Number of elements is equal to index, but then plus 1, right? So in this case, we need a minus 1 because we want the index, not the number of elements. Okay, so now we have our left and our right. So now let's start chopping things down. So while, and here we go. This is also one of those kind of things that I'm always confused about. Is it greater than? So like, for example, left is less than right. Okay, what I'm always confused about as well is it equal to? Do we try to process the one that is equal to? I'm not sure about that. We need to figure that out. So what do I want to do? I want to do mid is equal to and then this is just standard for binary search, left plus right, okay, and then integer division 2. Okay, standard stuff right there. Now, again, more stuff that trips me up. What do we want to do? Sometimes we have mid plus 1, other times we just have equals mid. So I'll show you what I mean by this. Okay, so now we have mid right here, and it is either good or bad. Now, let's see. How does this API return? So false means it is actually good. So is bad means false, it is not bad. Okay, cool. So what I'm going to do is I am going to do result equals, and then is bad version of mid. Okay, so I'm gonna put in mid and say, like, is this a bad version or not? Okay, so now what happens? I'm gonna get some result. Cool. So I got the result, and now if it is good, what do I want to do? Okay, so that corresponds to the case. Like, I got this one. Here's mid, and it's good. Okay, so now I know that all of those are good, so I need to be changing left. Okay, so now if result, okay, but remember, this will return false if it's good, so I need to negate that. So if not result, okay, then we're good. Then we are good. Okay, So in this case, I want to change left. Okay, so left is going to be equal to, and here we go, this is what I was meaning. I always get this mixed up. Mid. Or is it mid plus 1? Right, that is what I'm always confused about. Now, I'm thinking, I don't know if this is accurate, okay? I'm thinking that might have to do with my stopping condition, that I want to stop not at the last good, but actually the first bad. So this means that this left is currently pointing to a good, right? So I don't want it. I don't want this good. Okay, so I am going to move to the next one. Okay. Otherwise, then we hit a bad. So this is the case that we hit a good. This is the case that we hit a bad. Okay, so in this case, I want to change right. Okay. So now right is going to be changed. What is right going to be changed to? So let's come here and let's say that we ended up with this one. Okay. So I want right to be changed to be equal to mid. So right is going to be equal to mid. Now, question, is it mid minus 1? See? This is how I get all tripped up and mixed up and all contorted into all sorts of positions, right? This is the mind bender thing that I'm always suspicious about, like, what plus 1, minus 1, which one goes where, and what is the stopping, what's this one, right? Is it equal to, is it not equal to, is it, okay, so calm down, and we're going to look at this. Now, so is this minus 1? Maybe. We're going to be looking at it. That's a maybe right there. Okay. So, what did I do? Let's, I guess, so I came here, and do I want to include it? My instinct is to say, no, we just concluded, wait, hold on a second. We concluded that it's bad, and I want to return the first bad. So it could be the case that this is, so I think we do need to include it, actually. Because, okay, what if I'm looking at this one, and I found that it's bad? I don't want to change right. I know that the one that I'm currently looking at, mid, right? Like this one is either the first bad. So, okay, let me say that again. If I see a bad, let's say this one right here. Okay, I see a bad. I know that this element is either the first bad or it is not the first bad. Well, okay, that sounded a little bit more clear in my head. But I know that this is bad. So therefore, I know that all of these ones are not the first bad, right? So I can eliminate all of these and say, no, those ones are not the first bad. But if I'm looking at this one, that here's mid, and I see this one, I cannot conclude that this element is not the first bad because I haven't checked that yet, right? Let's say mid is here. Can I conclude that mid is not the first bad? No, but I can conclude that all of those are not the first bad because I've seen this one and this one is bad. So I think I want to change my mid, but inclusive of mid. So, or change my right, but inclusive of mid. So I do want to keep checking, and I'm going to just keep my right here. And then what am I going to do? I'm going to keep looking, and let's, I don't know, my left is here, whatever, right? And then I'm going to come here and say good, and then I'm going to change my left. Then I'm going to come here and say it's good. then I'm going to change my left. Okay, so I'm looking at this one right here. This is the last good, and I see it's good. And then I want to take my left and add 1 to it, right? Okay, I add 1 to it, and now left and right are pointed at the same element. It is pointed to the first bad. It's pointed to the first bad. I do not, left and right are equal to each other. It's pointed to the last bad. The last bad, or sorry, the first bad. It's pointed to the first bad. Left and right are equal to each other. It's pointed to the first bad. The first bad is the condition that I want to return, right? That is the element I am searching for. That's what I'm targeting. That's what I'm honing in on. So I do not want this right here to be equal to. Once they're equal to each other, I know that I have found the last bad. Or the first bad. Sorry, the first bad, which is what I am searching for. So once I finish this while loop, left and right will be pointed to the same element, and it is going to be the case that it's going to be pointing to the first bad. So I need to return, I think, either left or right. It doesn't matter because they should be pointed to the same thing. Okay. Now, all of that talk, does it actually work? Should we, I guess I'm going to try to think of edge cases first, and then I'll press the submit button. I feel kind of confident about this one right here. I'm really, I mean, if I hit submit and it doesn't work, I'm just going to feel crushed. But that's fine because we'll learn and I'll try to push forward. But, okay, so what would edge cases be? Let's say n is equal to 0. Okay. Is that constraints? So the number, so bad is greater than or equal to 1. So we don't have the case where there are no elements. Okay. Now, n is a large number. Okay, whatever. And n can be equal to 1. So n can be 1, and there's at least one bad. Okay? So the edge case would be n equals 1. In the case that n equals 1, what would that entail? That means that the only index is 0, right? So it's going to be kind of like this. So it's going to be bad, like this. So left is equal to 0. Right is going to be equal to, okay, here we go. Number of elements is going to be equal to 1, but then we're subtracting because we want the index. And this is going to be, so 0, 0. We are not going to run this because it is not equal, or they are equal to each other. Left is 0, right is 0. So we don't run this, and then we return 0. And the 0th index is the first bad. Okay. Let's try it. Expected 1. Okay. That makes it sound like, maybe I didn't, hold on. That makes it sound like it's like off by 1, and I'm thinking I'm returning the index. Maybe it wants the actual like number. Okay. So implement a function to find the first bad version. You should minimize the number of API calls. Okay, so bad is equal to 4. So I think what is going on is n equals 5, so there's 5 elements, right? And then this case is easier. So this is what I was just saying with like this. So I am right now returning 0 in this case because it's the 0th index which has the first bad. But what they're saying is actually we want the number 1 because it's like the version. Okay, so let's just give them what they want. So it's going to be the index plus 1. Okay, let's see if that works. If the no, darn, output expected, darn, that sucks. Why? Why? Does it, what about if I just press run? How about that? Does that work? No? Okay. This one works, this one does not. Again, this one is like off by 1. Let me, suppose you have inversions, okay? You want to find out the first bad one. Like it doesn't explicit. Bad equals 4. Does that mean like I'm just gonna try something because I'm not even sure what they're really asking. If n equals 0, return 1. I'm just gonna see if this like works. Like, is this what they're asking? Output 0. I don't like how they're mixing all of these index and dang man. So it's not that. But I'm off by 1. What about if I do like right? Would that affect anything? I don't think so because it stops when right is equal to left. So no, that wouldn't change anything. All that hope and happiness, and it turned to ash. Darn, man. Come on. I mean, I was feeling good about this one, and then no. Well, I'm trying to figure out, do I just ask for the answer? Do I okay. Inversions. I don't like that they don't explicitly tell me like what to return. You want to find the first bad one. Okay. First bad one. Like I don't like that word either. do I want the index or do I want I should be able to look at the examples and get that information. And I think the answer looking here is they want the actual like number, right? So I should be able to answer it, right? I'm using that as an excuse like, yeah, see, that's why I didn't get it. I'm using that as a crutch right now. I shouldn't be doing that. I should take responsibility for the fact that I can't get this problem. It's okay. Yo, like, hold on. What was the problem with it though? Like, what was it? N equals. Hold on. Let me just. What I'm gonna do is I'm going to go back here, look at this, and see what's. Okay, so I said it should be left. Okay, it should be left. Okay, now I want to return the number. Okay, so it should be this one. Here's what I'm saying right now, according to my understanding of the world, this is correct. Now, Leetcode says it's not correct. So there's some discrepancy. I'm going to press the submit. I'm then going to look at what it fails for and try to walk myself through that specific example and see why their solution, their expected, is not my expected, because there's some miscommunication about how the world operates. And I need to find that out so I can rectify it. Okay, so here we go. Submit. It's going to fail, and we're going to see what it fails for. Okay, wrong. N equals 5, bad equals 4. I'm saying 5. Why? So, I think this corresponds to the case. So we have N equals 5, so there's 5 elements. So we're going to go good, good, good. 1, 2, 3, 4, 5. Now, bad is equal to 4. Okay. So that means is it like this? So it bad equals 4. So that means the 1, 2, 3, 4 bad. Okay. 1, 2, 3, 4, right? So 4 starting at 1. So it's actually the index 3, right? 0, 1, 2, 3. So index 3, but number 4, okay, is the first bad. So here's the array that we're failing for. Let's walk through our solution and figure out, like, hey, what's up? Okay. So, left is 0, right is in, which is 5, minus 1, so 4. Okay. Could there be some problem that I'm doing this here, but these are like the number and this is the index and I'm trying to mismatch something? Could be. Could be. I'm suspicious of this line here. I'm going to put a little question mark. I'm suspicious. Let's say like, do that. Are we mixing numbers and indexes? Could be. Okay. But as of right now, it equals n, which is 5, minus 1, 4. Okay. 0 is less than 4. Good. Now, we want to go here. So 0 plus 4 divided by 2 is 2. Okay, so mid is 2. So I check if, and again, this is not the index. This is not the index. I think this should just be like this because I think we're mixing indexes. I think that's what we're doing. I think we're mixing indexes. Hold on, let me walk through this. Let's keep going. But I want to hit that submit button, see if it works. But let's keep walking through it. Okay. So now in is equal to 5. Okay, and my logic right now is I'm saying 5 is a valid solution for this problem. For example, I could have something like this, like good, good, bad, where this is 5. And so I want right to kind of include this value. And right does not actually mean index, because I'm making this API call here and I'm passing in mid, which is the middle point between left and right. But this function does not return good or bad based off of the index. No, it returns it based off of the number, right? The version. So that means I don't want the, oh, I shouldn't have done that. I kind of erased my, so I said good, 2, 3, 4, 5, and this one was bad. Oops. This one was bad, and this one was bad. This is what we have. So I'm thinking that this will work now because I'm submitting the middle point, okay, which is the version. All of these, this is version. So actually, could I say that this is going to be 1? I think I could. I think I can say 1. I think I can. And then this will obviously be still left, not left plus 1. Hey. Okay. So my logic, I think, was kind of correct. We were just getting a little bit confused about indexes versus number, right? Or version. Okay. Let's go. All right. And so this part was actually correct. My analysis about I want to find, what am I targeting? I'm targeting the first bad. And so, okay, my methodology for, I'm going to have to rewatch my own video to figure out how I actually did that. Because I was talking through it. And when I talked through it, it actually made sense. Nice. Okay. And this one is not inclusive because I'm changing right and I want to include this element because I don't know if it's the last element or not, or the first bad element or not. If I see a good one, I'm not interested in anything good. So I say, okay, this is good. I'm just going to skip you completely. It's mid plus 1. Here's mid. I just say, here, go here, right? And now I'm at this one. But if I come across a bad, I don't want to say, oh, this is bad. I go here, definitely. No, I don't definitely go there because I can't guarantee that this isn't the first bad. I can guarantee that all of these are not the first bad, but I can't guarantee this one, so I still want to include it. Okay, that's the idea. That's the idea. That's the idea. That is the idea. Okay. Then equals. I I followed through this and said what? What did I say? I said equals should not be included here because I am going to be targeting, I'm going to be coming across the first bad here, and that's going to be when left and right are equal to each other, and I just want to return that. Okay. Trying to continue to go through this. I'll have to rewatch my video, this video right here, because I think I actually, when I was talking through it to myself, I was able to, like, it made sense, I felt. Um, so awesome. Cool. Anyways, we finally solved. I think that this is the first binary search problem that I've actually solved. Hey, here we go. All right, so thank you guys so much for watching this video. I hope that it helped you. I hope that either it helped you or entertained you, whichever one suits you, right? So anyways, thank you for watching. My name is Timothy Lee Grant, and I will see you guys tomorrow with another Leetcoding video. Yeah, awesome. Oh, I feel happier now. Recently, it's just been like crushing because I've been like failing at these binary search problems, and I'm like, I don't feel like this is a difficult topic insofar as like binary search is not something which is classically thought of as difficult. Um, and then also like at work, I'm having difficulties with one of my projects, and I'm like, it's not working, it's not working. So I'm like, I go at work and I'm just like, feel like I'm failing, and then I come home and I also feel like I'm failing, and so it was like a double whammy. But it'll be okay. I'll get it. I'll get both of them. I'll get work and Leetcode, binary search, all of that. We're gonna get it. Don't give up. Keep moving forward. All right. Anyways, thank you guys for watching this video. I hope you have a wonderful day.